Hi, welcome to NCV Mathematics Level 2. Our topic is looking at the graph hyperbola and using the table method to construct it. Now in our problem we've got draw the graph of y is equal to 6 over x using the table method with a domain of minus 3 and x and plus 3. So x must be bigger and including minus 3 but smaller and including 3. We will go to our calculator, of course. We're using the Casio FX, and we will now program our calculator to draw the table. So here we've got our calculator. We are going to go to mode, table mode. We want to put in this equation y is equal to 6 over x. So we've got f of x, which represents y, equal to, we're going to have a fraction. So the 6 will be on top, and move our cursor down to get the x. We'll put in alpha x. We've got f of x equal to 6 over x, which is y equals to 6 over x. We will enter that with the equal button. Our start according to this instruction here must be a minus 3. Our end according to the instruction must be a plus 3. Our step will always be 1, and our values are created on our table from minus 3 right down to 3, all the values corresponding x and y values. If we just now enlarge that, we see that is the values over there. So just reading off minus 3, value corresponding for y will be minus 2, x is minus 2, y minus 3, x is minus 1, then y will be equal to minus 6. Careful here, 0, we will get an error on the calculator, because we have to divide by 0, and division through 0 is undefined, cannot be, so that's why the error is there, but also indicating an asymptote. And then 1 is equal to 1, 2 0.5, and 3 equals to 0.33. We've got now our table. We go into our Cartesian plane and construct this graph now using the table method. Before we do that, look at the asymptote. Just the graph gets close and closer to the y-axis and x-axis, but never touches it. X equal to 0, all the y-axis is the vertical asymptote, and where y is equal to the q value, which there is none over here, is the horizontal asymptote. So asymptotes, must remember, it's where the graph will try to touch the x-axis or the y-axis, but never gets close to it, or rather gets very close to it, but never touches it. So let's look at what the construction looks like. So here we've got our Cartesian plane, and according to our tables on the calculator, we are looking at point A, or rather the first point was minus 3 and minus 2. So if we put that point on, minus 3, minus 2, our next point on the calculator, the table, was minus 2 and minus 2 and minus 3. So we put on that point over there, minus 2 and minus 3, minus 1 and minus 6 was the next point. So minus 1, minus 6, we've got our first 3 points, and because our graph is positive, it must be in the first quadrant and in the third quadrant. So we've got all the points in the third quadrant. We're now going to the other parts on the calculator, and our 0 was undefined. Remember, we've got 1, a corresponding value of 6, and we've got 2 with a corresponding value of 3, and we've got 3 with a corresponding value of 2. We've got all our points here on this quadrant, we've got all the points in that quadrant. We're now going to join them freehand, and remember, we now must not cross the x-axis, must not cross the y-axis, asymptotes, and when we do draw that constructed, this is what my graph will look like with all the different points in there. Alright, just moving that up, A, B, C, D, E, F, all the points on the graph. This is what my graph must look like. My next problem is draw the graph of y equal to 1 over x minus 2. Again, we're going to use our calculator and going to program it to find the table of y equals to 1 over x minus 2. Once again, we've got our table mode. We select it on the calculator. We get f of x, which represents y. We have to punch in 1 over x minus 2. So again, it's a fraction with your numerator being 1. Your denominator, move down your cursor, will be alpha x. Move your cursor, gets minus 2. So we have got f of x equals to 1 over x minus 2, which is our equation. We will enter that now using the equal button. Our start is no domain given here, so if there's no domain given, we can start at minus 2 normally and end at plus 2, and step will be 1 and our table will be created. So that's going to be minus 2 up to plus 2, all the values corresponding x and y. So now we can look at what that will look like on our enlarged. There we've got our values. From minus 2 it's minus 2.5, minus 1 is a minus 3. Again the error for the asymptote at 0, for 1 it's a minus 1, and for the value 2x and corresponding y will be minus 1.5. We can now go to our Cartesian plane and construct using this table. So here we've got our Cartesian plane, and the points on our calculated table was for minus 2 you'll get a minus 2.5, for minus 1 we will get a minus 3, for plus 1 we will get a minus 1, and for plus 2 we will get a minus 1.5. So here again asymptote will not touch those parts. Again here we've got an asymptote, but this time we've got a q value of minus 2. So if there's a q value of minus 2, we need to put in a line at y equals to minus 2, and when we do that, y equals to minus 2, the line will be drawn over there, and when we construct our graph we will see this will be the new x-axis. The graph will not touch those x-axis over here, does not touch the y axis over there, and this is how we construct the graph of y equal to 1 over x minus 2. So minus 2 is our q value, our new x-axis, and will be the asymptote for the x, and this will be the asymptote for the y. And this is how we construct graphs using the table method.